This question says, suppose a 500 milliliter flask is filled with 0.7 moles of methane, 1.2 moles of water, and 1.5 moles of carbon monoxide. And this reaction becomes possible. So we have methane plus water yields carbon monoxide plus hydrogen. This is actually the way commercial hydrogen is produced. And now we want to complete essentially the ice table, initial change and equilibrium, or ice table, below. So we need to find the initial concentration of methane, water, carbon monoxide, and hydrogen. However, unfortunately, we are only given moles of each of these compounds. We're not given the molarity. So to find concentration, we have to divide each of these moles by the half of a liter, 500 milliliter flask, or half of a liter, which means that the methane is 1.4 molar. Divide this one by the same half liter, which is 2.4 molar. And same for carbon monoxide, divide by the half liter, which is 3.0 molar. Now, in order to avoid having to put units on everything, I'm just going to put the units out here because these are all molarity. I guess you could put them on the top ones too, but we're going to put in these concentrations. So the initial concentration of methane, what we start with, is 1.4 molar. In the case of water, it is 2.4 molar. In the case of carbon monoxide, it is 3.0 molar. And we didn't add any hydrogen to the flask, so the initial concentration of hydrogen is 0. Now the change. Well, what's going to happen? As you mix these things together, the reaction is going to start to occur, and methane is going to start to react with water to form carbon monoxide and hydrogen. So this is basically what's going to happen. So what we need to use is the stoichiometric coefficients. And you remember that if there is no stoichiometric coefficient, the stoichiometric coefficient is 1. So as this reaction proceeds, and it's going to go in this direction, we are going to lose a methane. 1 methane, because the stoichiometric coefficient is 1, and that's x. We're going to lose a water. And again, it's 1 because the stoichiometric coefficient is 1. We are going to gain, they don't put the plus sign. You may see this in class with a plus sign here. But x, you're going to gain carbon monoxide. And you're going to gain 3 hydrogens because the stoichiometric coefficient is 1. So essentially what this is saying is, for every 1 methane and 1 water you lose, you gain 1 carbon monoxide and you gain 3 hydrogens, which makes perfect sense. Remember that this is a elemental reaction, so you're going directly from one of these plus one of these yields one of these plus 3 of these. So this is what we get here. So at equilibrium, what are you going to have? Well, you're going to have, for methane, you're going to have your initial 1.4 molar minus whatever you lost. In the case of water, you're going to have your 2.4 molar minus whatever you lost. In the case of carbon monoxide, you're going to have the 3 molar you started with plus whatever you gain from reacting the methane and the water. And then finally, for hydrogen, you're going to have 0 plus 3x, or simply 3x. Note that on the ALEKS answers, it doesn't actually have these pluses. I don't know if they can be there or not, but sometimes you see pluses here. It doesn't really matter whether you put the plus in or not. I'm just not sure if it matters when you're actually entered the answer into ALEKS. It also clearly says here you can leave out the molarity symbol for molarity. I put it here so I didn't have to write it 9 times or whatever, 12 times. All right, so this is basically how we would solve this problem.